Okay, so we're going to learn how to plot functions in LabVIEW, which you need to be able to do to basically write any of the programs we're going to write. Um, so what is a function? A function is just basically two lists, one of your x points, one of your corresponding y points. And then if you kind of draw a line between that, all of those points, you get a function. So these are simple line functions where y equals x. So for each x point, you can calculate what y is, and it's just the same number in this case. So if you want to be able to plot this function, first thing you need to be able to do is generate your independent variable, which is x. So to plot the same function, I could do it in any number of ways. First of all, I need to plot it over some range because this function goes on forever. It goes from negative infinity to infinity. Here I've plotted it from x equals 0 all the way to x equals 1. We're going to call the smallest point x min and the largest point x max for the purpose of our program. And you also need to know how many points you're going to use between that range to define your function. So here I only have 3 points, which is more than you need to define a line, but for most functions you'll need a lot more points than that. Here's another way I could plot this function. Here with x min equal to 25, x max equal to 100, so I'm plotting it between 25 and 100, and I've used 4 points this time. Okay, so let's get into our program, and what we know we're going to need if we want to generate a list of x points here is we need to know we need to be able to input an x min, we need to be able to input an x max, and we need to input a number of points. And that will give us the ability to generate any sort of list of points we could use to define a function. So here we go. Here's your LabVIEW program. First thing you should do when you write a LabVIEW program is create your inputs and outputs. So I'm going to make a numeric control. Call it xmin. I'm going to make another numeric control. Call it xmax. And I'm going to make a third numeric control. I just copied, pasted that. Called points. And that's all we need to define our list of numbers that are going to be our x points. And now we just need the output, which is our list of numbers. So how do you make a list of numbers in LabVIEW? Easiest way is to make a numeric, well, control is an input. We want an output here. So make a numeric indicator. And you'll see that for every object I'm putting here on the front panel, you get a corresponding object on the block diagram. Front panel is kind of our interface. Block diagram is where we do all of our computations. For this numeric output, I'm going to call that x points. And this is only a single number. I want it to be a list of numbers. In computer programming, a list of numbers is called an array. So I'm just going to right click on it, go to change to array. Now we got this, it looks a little bit different. If I click on the bottom edge here, you'll see what I actually have as a list of points. This is the index. So if I had a really long list of numbers, for instance, I'm just going to put some numbers in here. So I guess I should put different numbers in here so you can see what's going on. Say I was only displaying 2 of these, the index just lets you scroll through all the values. Okay, so this is just for viewing purposes here. Okay, so let's generate our numbers, which we're going to have to do in our block diagram. There's only a few there's a special way you need to start thinking when you're writing computer programs. And one of them is that computers are very good at doing the same process over and over some huge number of times. And so if you want to repeat a process, you want to use something called a loop. And if we right click here and go to structures, we can create the simplest type of loop, which is a for loop. This lets you drag a box on the block diagram, and everything inside this box will be repeated n number of times. So how many times do we want to repeat whatever our operation is here? Well, we want to generate points, number of points. So if we want to generate 10 points of a function, we'd want to make a point 10 different times. So I'm going to wire the points variable, the points input directly into n here. Okay, so now if I make this 10 on the front panel, when we run the program will execute whatever's in this box 10 times. The other kind of thing you'll see in the loop here is this I, which has a output value here. This is the index of your loop. This value starts at 0 the first time the loop is run and increases by 1 every time. So if I wire this to points here, maybe I should show you this really slowly first. I'm just going to put an indicator right here. So whenever you see a wire, you can always right click and create an indicator to have something show up on the front panel that shows you the value. And I'm just going to run this program as is. Right now it's going to go through this loop 10 times really, really fast, faster than you can see. So I'm just going to put a delay in this loop. If you go to the timing box here, there's this wait function. And it says milliseconds to wait is the input. And I'm just going to make it wait 1,000 milliseconds, which is a second. So now it'll take 1 whole second to calculate this, each iteration of this loop. And so it's a little bit easier to see what's going on. So when I run the program, if you look at this numeric box here, it starts at 0. Now it's 1, 2, 3, 4, 5. And it'll go all the way up to 9. And then the program will stop. Okay, so every time this loop runs, this I value increases by 1. I don't care about actually looking at this in real time, so I'm going to get rid of that wait. I want this program to execute as fast as possible in the end. And I'm going to show you what happens when you take this I wire and wire it to the edge of your loop. You see that the wire changes a bit. It gets thicker, and that's because it's turning from a single number into a list of numbers. So by default, what will happen when you wire a wire from the inside of a loop to the outside of the loop is it's going to do what's called auto-indexing. You can see it says auto-index tunnel. And that means it'll take the value of that wire for each iteration of the loop and put it in a list. So now if I run the program, you see that X points has been auto-filled with numbers between 0 and 9. Okay, and if I were to make points 5 and run it, now it makes a list of numbers between 0 and 4. So that's pretty useful. We're already kind of making X points, but we're a little bit limited, right? Because we don't have control over X max and X min yet. Our list is always starting at 0. And the number is just incrementing by 1 each time, no matter what value we want to end our function at here. So how do we shift this? Or how do we make this count in smaller steps? How do we make it increase by, say, 0.5 at a time instead of 1? Well, that's pretty easy. All you would do is you would take this number, say you wanted to increase it by 0.5, and multiply it by 0.5. So I'm just going to go to this numeric tab here, find the multiply function. You multiply the values of X and Y together. calculate the result. So there's your first number you want to multiply. I want to multiply this by 0.5. So I'm going to create a constant on that terminal. Make it 0.5. Actually, by default, what it's done, because it's blue here, it's an integer number, so it can't be decimal values. But what I can do is right-click on it, go to representation, go to double precision, which is these orange numbers that can have decimal values. Type in 0.5. Why does it do that? Just in case you're really concerned about how much memory you're using in your computer to store these values. There's a different amount for integers of different sizes versus decimal numbers. So there's I times 0.5. We're going to take the result of that multiplication and wire that into x points now. And you can see when I run the program now, we are incrementing in 0.5 values. Because first time this runs, this is 0. 0 times 0.5 is 0. Second time this runs, this value is 1. 1 times 0.5 is 0.5. And so on. And you can do those calculations for each iteration in your head or on paper or something until you get used to doing it. That lets us change our increment there. Now what we want to do is change our start value. We want to be able to start, let's say, like at -1. How would you do that? Also easy mathematically. We want to take our calculated value here and we want to subtract x min from that. So I'm going to wire x min into the subtract there. And when I run it now, if I make x min -1, oh, oops, I actually want to add x min. So I'm going to right click on that, replace with an add. There we go. So first this goes through, calculate 0, add a -1 to that, and you get -1. So everything has been shifted by the x min value. If I make this -2, that starts at -2 and so forth. Okay, that's pretty easy. But this program isn't still working exactly how we want because we're not actually using x max here. And we're always incrementing by 0.5. So how can we, instead of just putting in a constant value of 0.5, how can we calculate what this increment should be based on x max and x min? Let me pull up this PowerPoint I made here. Okay, so let's say we have a list of numbers between 0 and 1. You can always start with the simplest case. And you're defining your line with 2 points. Then your increment value, which we're going to call dx, is going to be 1, right? There's between your 2 points here, there's a distance of 1. If you have 3 points between an x min of 0 and an x max of 1, then your dx, your distance between your points here, is 1/2. We're going from 0 to 0.5, 0.5 to 1, so that's each of these lengths is 1/2. So on, if you have 4 points, the lengths are 1/3 here, these increment values. And if you have 5 points, the increment is 1/4. So how do I calculate dx from the values of x min, x max, and the number of points? You might already have figured this out from your pattern, but dx equals the length of your line, which is x max minus x min, divided by the number of points minus 1. Seems a bit weird to have the -1 in there, but you'll see that that's the case because you've got this last value. You have 3 points. That's your length, which is 1 over points minus 1. So for 3 points, you have 1 over 2. For 4 points, you have 1 over 3. For 5 points, you have 1 over 4, and so on and so on. So this is what we want to calculate in our program to figure out what our increment dx is going to be. So we're going to take x max minus x min. And then we're going to divide that by points minus 1. So there's two ways we can do that. We could do just this normal subtract. Going to branch off of this points value. You can use that value more than once to do more than one different things. You can create a constant and say points minus 1 like that. Wire that in. Or there's actually kind of a shortcut function in the numeric tab, which is just this decrement function. It just subtracts 1 from whatever your value is, because this is a pretty common operation. And so there you go. So now we have points minus 1 divided from x max minus x min. And that is our new dx. That's our new increment, our calculated increment. So I'm going to wire that into this multiply here. Okay. So does it work? Let's see if I go try some simple cases here. If I go from 0 to 1, like in my example on the slides, 2 points, that should be 0 and 1. 3 points, should be 3 evenly spaced numbers, 0, 0.5, and 1. 4 points should be 0, 1/3, 2/3, and 1, and so forth. So that seems to be working. If I start at a different x min, let's do -5 to 1. Yeah, that's fine. I have a increment of 2 each time now, -3 or -5 to -3 to -1 to 1. Yep. So still getting a evenly distributed number of points between x min and x max. Okay, so our program works. You can see already how in LabVIEW, a graphical programming language like this, your code can start to get really messy with these wires. So it's worth, as you're doing it, kind of keeping everything really clean. So every time I kind of complete a section, I'll go back and clean it up. A couple ways to do that. One, you can, if you click this cleanup diagram broom button, it'll kind of straighten all the wires for you. So you see, you just kind of condensed everything. It doesn't always lead to the most, to the cleanest looking diagram. I kind of like just doing it manually a lot of the time, because it kind of helps me internalize all the connections I made. So you just kind of want to make sure that no wires are crossing, or you avoid that as much as possible. Don't want too much white space. So this is how I'm going to organize mine. It's going to make that loop a little smaller. It's going to space things out a little bit. We've got sort of some unnecessary wires crossing here. So what I'm actually going to do is swap these inputs. If you hold down the control button, you can swap what wires on top and what wires on the bottom of these functions. So there we go. I just swapped the top and bottom wires here. So now I can move this over. Definitely don't ever want any wires going backwards, because that's really confusing. We can make this smaller. We can move this down. We can condense this stuff. So I'm not going to show you how I clean up every program because, you know, there's no right way to do it. It's just a waste of video space, but I just wanted to show you how to do it. How I do it this one time. Just maybe to help you get in the same habit. And another thing you can do, if you find these inputs and outputs to look too big on the block diagram, you can right click on them, uncheck the view as icon, and it'll shrink them down and also kind of tell you what type of data they're holding, which can be convenient. And that can let you fit things a little closer together and so forth. All right. So that's how you write a program to generate a list of points. And in the next one, you know, we will make the y values. We'll turn these x values into y values for some given function.